Hello friends, today I am going to teach you the very important question, that is the heating effect of current. I hope you like this video and subscribe my channel to getting more videos, and I also hope that it will help you for your examination. So let's start the video. Explain the heating effect of current. The question is that explain the heating effect of current and state Joules law of heating. First, we have to explain the heating effect of current. Then, we have to state the Joules law of heating. Define electric power and calculate energy consumed by 100 watt and 220 volt bulb in 2 minutes when connected to 220 volt source. This is the problem. This is given the problem. First, we have to define the heating effect and state Joules law of heating. So then the answer is that we have to take one conductor. Okay. Here let a current I. First we have to take a conductor X and Y. That conductor is XY. Okay. And I current is passing through the conductor XY. This is the current I which is passing through the conductor XY. This is the battery, and its positive terminal is this and its negative terminal is this. Now let V1 and V2 are the potential difference at X and Y end. Here this is V1 and this is V2. These are the potential difference. These are the potential difference at the end X and Y. Getting this now? Here V1 is greater than V2. The potential difference at the end X is greater than the potential difference at the point Y. Next, now change in potential energy. Change in potential energy. We knew that potential energy U, change in potential energy is equal to U1 minus U2. How can I calculate potential energy? Potential energy U is equal to VQ. This is the formula. V here, the V is potential and Q is the charge. Potential energy U potential energy U is equal to potential V, electric potential V into charge Q. Here in this conductor, electron is passing from the end Y towards the end X. So the charge of electron is that minus E. Charge of electron is that minus E. And we getting the charge, that is minus E, and potential is equal to V. So dU, change in potential energy, that is dU is equal to U1 minus U2. Here at the end U1 the potential will be, at the end U1 potential is minus E, charge is minus E, V1 minus of minus E V2. I hope you getting this. Here the potential energy U is equal to minus E V1. U1 is equal to minus V1 and U2 is equal to minus V U2 minus V U V minus E V2. Okay. So getting common minus E, we get dU is equal to minus E whole into V1 minus V2. This is equation 1. As dU is negative, this indicates, that means that there is loss of potential energy. The potential energy is lost due to electron moves from y end to x end. Electron moves from y end to x end. Okay, from y end to x end, electron move towards this arrow mark. So this that electron are moves from y to x. As electron moves with constant drift velocity, here the drift velocity is constant. The electron are moved from y to x end, but the drift velocity is constant. Here the drift velocity is constant. So there is no change in kinetic energy. Potential energy is changed. Potential energy is changed, but kinetic energy does not change. So due to the kinetic energy does not change due to the constant drift velocity. Okay, so here kinetic and change in kinetic energy will be 0. This is equation 2. We take equation 1 as a change in potential energy and take equation 2, that is change in kinetic energy. So total change in energy, that is work done. Total change in energy is work done, that is dW, change in work done, is equal to change in potential energy plus change in kinetic energy. Change in kinetic energy plus change in potential energy. As change in kinetic energy is 0, so dW is equal to change in potential energy, that is EV. This is equation 3. Are you getting this? If n number of electrons are crossing from y to x end, we didn't know how many number of electrons are moving from y end to x end. How many number of electrons are moving from y end to x end? So let if n number of electrons are crossing from y to x end in the time dt, then total energy of the system will be n into, we know charge is equal to q is equal to ne. So we multiply n here, we get dW is equal to minus ev. If there are n number of electrons, so dW will be minus nev. This is equation 4. We get equation 4. Now according to the law of conservation energy, we have to put the law of conservation energy, that in law of conservation energy, what's the statement of law of conservation energy is that energy can neither be created nor be destroyed. It is transferred from one state to another state. Okay, so according to conservation of energy, we get that potential energy is lost. Is potential energy is lost, so it does not obey the conservation energy. So to obey the conservation energy, according to law of conservation energy, the net heat produced by this work done. The net heat produced by this work done. The heat is magnitude. So dH net heat is equal to NAV. That is equation 5. Can you understand it? Now E is equal to I into dt by n. This is n. How can I getting this? We know current I is equal to charge per time, Q by T. Okay, Q by T. Here Q is Ne. So Ne by T. We get E is equal to I into T by n. Here T is dt. So I into dt by n. This is n. This is not h. This is n. Okay. Putting the value of E. We have to put the value of E in equation 5. we get dH is equal to N into E. E means I into dt by N into V. N is cancelled. N can cancel. We get VI dt. This is equation 6. Okay. Now total heat produced. We derive the change in heat produced, so we have to derive the total heat produced. So we take integration of heat dH from limit 0 to h is equal to Vi into dt 0 to t. Here Vi is constant, so constant will be extracted from towards the outside. Okay, we get H is equal to VIT. This is Joules law. According to Ohm's law, V is equal to IR. V is equal to IR. We know from Ohm's law, V is equal to IR. Putting the value of V in this equation, we get VH is equal to IR into IT. That is I square RT. Okay, I square RT. We get H is equal to I square RT. This is equation 8, which is your required equation. So H is measured by unit joule. H is measured by unit joule. When heat is measured by calorie, this is I square RT by J, where J is the joules constant, that is 4.2 joule per calorie. If we want to convert joule into calorie, we have to divide 4.2. Equation 9 knows as Joules law of heating effect. So we have to state here what is Joules law of heating. Joules law of heating states that the amount of heat produced in a conductor. Amount of heat produced in a conductor due to current flowing through it. Okay, amount of heat produced in a conductor due to flowing of heat through it. It states that how many amount of heat is produced in a conductor. In that conductor, how many amount of heat are produced? That will explain in Joules law of heating. Now, law of current. In Joules law of heating, we have to determine the law of current. That is where H is equal to I square RT. Okay, so H is directly proportional to I square. H is directly proportional to I square by taking R and T constant, where R and T are constants. So mathematically I is directly proportional to I square and R and T are constant. Now taking law of resistance, H is directly proportional to R, where I and T are constants. Similarly, in time, H is directly proportional to T, where I and R are constant. This is all about Joules law of heating. Now, electric power. Electric power is defined as the rate of use or supply of electric energy per unit time. That means in time t, how many amount of electric energy are supplied, that is known as electric power. Now solve the problem. What is the problem given? That is 100 watt having 220 volt bulb in 2 minutes. So here the P, that is power, is 100 watt, potential V is 220 volt, and time is 2 minutes, that is 12 seconds, that is 120 seconds. So energy consumed, E is equal to, we know E is equal to P, power into time. Okay, so power is 100 into time 120, that is 12,000 joule. So we get 12 into 113, that is 12 into this is not 103, this is 12 into 10 to the power 3, 10 to the power 3, that is 12 kilojoule. Okay, can you understand it?